Just a brief overview, definition of statistics and things like that. Oh, and hold on a sec too. You can enter full screen with this. I should have showed you that earlier too. Enter full screen and it's a lot more user-friendly, I think. So we start out in section 1.1 looking at a definition of statistics. This is broken down into descriptive statistics, which order-wise is the first thing we're going to cover in this course. And then it gets into inferential statistics. One of the important things that you need to ask what individuals are to be included, what variables are going to be measured or observed. Then what about the source of the data? Are we going to obtain data from the entire population? Are we going to take some representative sample that's a subset of the population? It's going to get to the point where most of what we do, they're taking a representative sample that's a subset of the population and randomly selected. You'll need to be able to classify data. You're going to see some of this stuff on your first test, but again, you can print this out and use it on your test. Classification of data for the variables, is it quantitative or qualitative? In other words, quantitative is numerical values like height, weight, age. Qualitative is non-numerical. It's categorical data like sex, hair color, name of the city, name of a car that you're driving, that type of deal. You'll also need to know how to classify which of these levels of measurement data falls into. And this is from the least to the greatest, so to speak. Nominal data is characterized by name only. So for example, states, cities, hair color. Ordinal data is data that can be arranged in an order. For example, good, better, best, first, second, third place in a race, something like that. Interval data, the differences between data values make sense. So for example, years in which Democrats won presidential elections. Temperatures in degrees Celsius or Fahrenheit. Interval data has no inherent zero, okay? So for example, 0 degrees Celsius or 0 degrees Fahrenheit doesn't mean absolutely no heat whatsoever, no molecular movement, right? That actually falls under ratio data. So this is the highest classification is ratio data. Ratios between the data make sense. An inherent zero exists. For example, length, height, degrees Kelvin as opposed to Celsius or Fahrenheit. And remember, as you're going through and taking the test or trying, looking over some of the problems, we classify according to the highest level that applies to all of the data, because something that is at the ratio level also has other levels of measurement below it that are a part of that, but in some instances, but we want to name it by the highest level of measurement. So remember that. Out of this first section 1.1, make sure you look over problems 7, 9, and 11 at least, if not more, and look at the examples worked out for you. The answers are in the back of your textbook. I haven't gotten to the textbook yet, but I'll show you where to find that. And I'm going to go on and just cover 1.2 here with you as well. Oh yeah, so and I might have already said this, but for all of the notes, I put in recommended homework problems for that section. Section 1.2, we're talking about obtaining random samples. So how do we obtain random samples? Do we want our samples to represent the population? And what's the best way to do this? Well, there's different ways that you can do this. One of the reasons we want randomization, though, it enhances the validity of the study, whatever your data study is that you're collecting the data for. Internal validity, conclusions about cause and effect relations are valid, and external validity in that it can be generalized to other situations. Generalizability, as they write it in your textbook. So a couple of different sampling methods. First, a simple random sample. So some number n measurements are taken from a population such that these two things are true. Every sample of size n from the population has the same chance of being selected. And then secondly, every member of the population has the same chance of being included in the sample. So how do we get a simple random sample? Well, computers and your graphing calculators have random number generators. In the back of your textbook, they have random number tables, Appendix 2, page A9, Table 1 for a random number table, if you want to look that up. So how do we use a random number table? And you'll see something like this, selecting a random sample using a random number table, except I'm going to give you the numbers so that everybody gets the same answers on the test. So here's a group of numbers. They put them in groups of 5 going up and down a page, right? So let's say we want to select a random sample of size 5 out of a population of 600. Like it could be, for example, in an automobile plant, and you want to select randomly 5 of those vehicles coming down the assembly line out of a population of 600, okay? So what you do is you look at your population size, 600, and you notice that it has 3 digits, 600, right? So you look at the size, and 600 has 3 digits. So what we do is we break this data up in groups of 3 digits. So I go to the 513, and then there's a break. Then the 219, there's a break. Then the 224, and so on, right? And so then you just go left to right. And if the number is from 1 to 600, that's the population size in this case, select it for the sample. But if it's not, you ignore it. Okay, if it falls out of that range. Also ignore repeats. We're sampling without replacement. Don't count the same card twice, in other words. And we continue until we have 5 numbers because we wanted a sample of 5, right? Up here. So our sample 513 falls in the range, so that's going to be one of them. 219 falls in that range. That's going to be one of them. 224 is also going to be one of them. 680 is too big. It's beyond 600, which is our sample size. So we skip it. We go to the next one. 088 is 88. Okay. 770, we skip, right? You don't see it down here. And then 748, nope. 872, nope. 256, yes, that's our last one. So we've selected our 5 items out of this population of 600. So that's simple random sampling. By the way, this is not an exhaustive treatment of sampling. There are more methods of sampling, but this is like the standard elementary statistics level sampling overview. Stratified sampling. The population is divided into strata that share some kind of common characteristic, age, for example. Then random samples are drawn from each stratum that you have divided into. So for example, Cloud County community students are divided into freshmen and sophomores. 25 freshmen and 25 sophomores are randomly selected to rate student services. I'm making this stuff up myself, but it is stratified sampling. Systematic sampling, members of a population are sequentially numbered 1 to whatever the sample size is. And then the way your book terms it, every kth member is in the sample. So like if it's 5, you would select every 5 items coming down an assembly line. And I don't know if you know who Spacely Sprockets is. I'm pretty old. It's from an old series called TV cartoon called The Jetsons. Every 10th sprocket coming down the assembly line at Spacely Sprockets is inspected. And then I ask this question, what's a potential problem with this? Here's the problem. When there's systematic sampling and you're using some kind of robotics or machinery to select those samples, it could be letting samples through that are actually damaged somehow, but they're not going to be picked up all the time if you use this systematic sampling, excuse me. So you got to watch out for that. Cluster sampling. An entire population is divided into pre-existing clusters. This is often used in geographically based situations. Clusters are then randomly selected, and then every member of that selected cluster is included in the sample. So an example of this, in order to conduct an opinion poll, the population of Kansas is divided into clusters according to the first 3 digits of the phone numbers. 10 clusters of the prefixes are randomly selected, and then everyone in that cluster, all of the customers with the phone numbers in that cluster is polled. And then you have convenience sampling. Readily available members of the population are sampled. For example, students in this class or in my class here on campus are selected to obtain data on GPAs, that type of thing. So again, it's sampling out of convenience. Or it's like if you're standing outside of a restaurant or something like that. Stand outside of a restaurant and you're just grabbing some random people that are coming out of that restaurant to get their opinion about something. Then there's multi-stage sampling, in which what you've seen previously, some of these different sampling methods are mixed up. A variety of sampling methods is used to create successfully smaller groups at each stage. And then the final sample is going to consist of clusters, like related to the cluster sampling. So you get everyone that's polled. And then out of here, I would recommend taking a look uh, homework-wise at problems 13, 17, and 19. And again, check them in the back of the book. And if you need to, go and actually look through the text and find examples that they've worked out for you, please feel free to do that. And as always, if you have any questions or need any help or anything like that, please feel free to contact me. Good luck. Yep, here we go. Stop.